All right, thank you so much for joining us today. And in this video, we have integration questions that we want to go through together, right? But before I start, I just want to give you some, tips, right? So one tip that you need to know is, we started the idea of differentiation and we are just doing differentiation types of differentiation, right? Now, with integration, one thing that I would like you to know is if you know how to do differentiation, then integration is basically bonus. Why? Because if I differentiate ln x, I know that I'm going to get 1 over x. So anytime I'm integrating 1 over x, then I need to get the function of what? Ln x. So that is the idea. So the functions that we differentiated, the results, when we integrate the results, we need to get the functions that we differentiated, right? So now before we start, we need to know that when I want to integrate a function to the power x, right, this is actually is like x plus 1 divided by n plus 1, sorry, x to the power n plus 1 divided by n plus 1 plus c, because we are adding the plus c because we don't have this one here, right? So it's indefinite, like kind of. So we don't have this one here. So we add plus c. Another thing that we need to know is if I'm integrating a function of the form like 1 over, let's say, x to the power n, n can be a fraction. But here, what I'm going to do here, when it is in the form of fraction here, it implies that n is not equal to 1, except when n is not equal to 1. This one can be written as x to the power minus n dx, and then I apply the same power rule there, and I'm going to have x to the power minus n plus 1 divided by minus n plus 1 plus c. Now the question is, what if n is 1? When n is 1, 1 over x, that is when we have 1 over x, the x. And we are saying that I just said that what function that you differentiated and you had 1 over x, that is the ln of x. So this is going to give us ln of x plus the constant c. So that's one thing that you also need to learn from here, right? So now we know that if the function is of the form this, we can change it to this form and then use the same power rule here to do it. And then when it is 1 over x, it is ln of x. Another one that you need to know is when I'm integrating exponential function, let me say e to the power x dx, this is equal to, I maintain the function, then I will divide it by the derivative of what is on the top. So what is on the top is here. So basically, let me just change what is on the top here to x. So I'm going to just differentiate the top, what is the x there. So you can see that I'm differentiating what is on the top here, right? Then I add my plus c. So that is the idea. Or before we go through this discussion sheet, these are some key points that you need to know. Then maybe the other thing that I want you to know is whenever I have a radical function, right? Whenever I have a radical function, I try to change them first. So this is going to be x to the power 1 over 2 dx. Then whenever you have something like this, you apply the power rule here. And also when I have something like 1 over, let's say, the same radical function dx, we know that this one can be written as 1 divided by x to the power 1 over 2 dx, and then this is going to be integration 1 over x, integration x to the power minus 1 over 2 dx. Then you also apply the same thing here as well. Now here we cannot just move this one up here when the top here is -1, right? So what you need to know is this one here can be written as x to the power -1 dx. So anytime I'm integrating x to the power -1, I need to think of the idea of a ln function. Yeah, so this is what is going to guide us through the worksheet here. So now let's start with the first one. So the first one is going to be equal to, so we are using the power rule here, right? So I'm going to have 3x to the power 2 plus 1 divided by 2 plus 1. So as we see it from here. So here our n is 2, so we add plus 1. So you can see that everything on the top here is the same as what is over here. So 2 plus 1, 2 plus 1 here. Then minus 5. Now x is to the power 1. So I'll add plus 1 divided by plus 1. Then plus, oops, I think I didn't talk about when you are integrating a constant function. So when I'm integrating a constant function, let's say 1 dx, now you ask yourself, what function did you differentiate it and you had the 1? Remember, if this is with respect to x, then it means that that is going to give us x. So anytime I'm differentiating a constant function, I pick the constant function here, then I multiply by what? X. It means that if I'm integrating 2 dx, this is going to give us 2x, because when I differentiate 2x, I'm going to have 2. When I differentiate x, I'm going to have 1. So that's the idea, or what I was trying to bring your attention to when we started. All the results that we are going to get at the end of doing the integration, when we differentiate them, we need to get what is there. All right. So this is going to give us x plus c. So let's try and simplify. This will be 3x to the power 3 divided by 3 minus 5x squared divided by 2 plus x plus this. And then this is x to the power 3 minus 5x squared divided by 2 plus x plus c. So you will see that when I differentiate x, I have 1. When I differentiate 5 over 2x squared, I will have minus 5x, because the 2 will drop down, multiply this to be 10. 10 divided by 2 is 5, and then I subtract 1 and I have my x here. When I'm differentiating this, 3 drops down, subtract 1, and I have 3x squared. So anytime you are done with the integration and you want to verify and you are not sure of what you have gotten, you can try to differentiate your final results and see if you are going to get this one here. When I differentiate the constant, I get 0. So you see that I get exactly what is on the function there. All right. So let me try and do B. So my workspace is kind of using all of them. Let me shift this one small, and then let me try and do B. So B here, this can be written as, so you see, I have 2 over 3 here. 2 over 3 is a constant function multiplying something. So I can write this one as 2 over 3 out. And I'm going to have integration 1 over x to the power 4 dx. So this can be written as this. So I just wanted you to know how we can write that one. Then let me just clean this and shift this one small so that I can have space. So this is where I'm writing the B. And then this can be written as 2 over 3 integration x to the power minus what? 4. So now we can see that this degree here is 4, not 1. So we are not thinking about this, but we are thinking about this. Right. So now let's go. This is 2 over 3 x to the power minus 4 plus 1 divided by minus 4 plus 1 plus the c. And this is going to give us 2 over 3 times x to the power minus 3 divided by minus 3 plus c. And then our final results should be, when I multiply, I should have something like minus 2 over 9 x to the power minus 3 plus c. So this is what I'm going to get as my final result for the B, and this is for the A. Good. Good. My board is so mess, but I think it's okay. Let's look at C here. So integration 2 over 5x dx. This can be written as 2 over 5 out. What will be left? 1 over x dx. So now we have 1 over x where the degree is 1. So what we need to think about is we need to think about this guy here. So I'm going to have 2 over 5, and then 1 over x is ln of x plus c, which is very simple, right? Good. Let's look at the D. I have integration 3 minus 2x dx. This is equal to, now we said when I'm integrating a constant, I just multiply by what I'm integrating with respect to. So this is with respect to x. So I multiply 3 by x. I'm going to have 3x. So that when I differentiate 3x, I get 3. Right. Good. Then minus. Now we learned from how to differentiate this function here. We said maintain the function and divide it by differentiating what is on the top. So what is on the top here is 2x. So when I differentiate 2x, what am I going to get? 2 plus c. That's what I'm going to get for the d2 as well. Let's look at e. So e is like 2x plus 3, 2x plus 3. Some of you can use integration by substitution, which is okay. But if you don't know how to use integration by substitution, then for me, the best way to do is write this one as, since this one is squared, write this one as this and that, right? And then I'm going to expand that. So multiply that. So maybe let's do the expansion and bring it there. 2x plus 3, 2x plus 3. So this time this is going to be 4x squared. This time this is going to be 6x. This time this is going to be 6x. This time this is going to be 9. So 4x squared plus 12x plus 9. So this is going to give us 4x squared plus 12x plus 9 dx. And when I do the integration, I'm going to have 4x to the power. So right now we know how to do it. We know that we need to add 1 to this. So I'll just write it straight. 3. Then since I've simplified the top to be 3, I need to make sure that the power here is the same as what I'm going to write here. So this one too is going to be 3, right? Plus 12x. This is to the power 1. Add 1 to it, get 2. So I'll divide by 2 plus, when I integrate a constant, I get a constant times the x. Then I add my c. So if I want to simplify, 4 over 3 x to the power 3 plus 6x squared plus 9x plus c. Right, so when you become good, you can just move very fast. So this is what you can do, right? This is what you can do. Let's look at the f. The f is nice because what I need to do is, first, I know that a plus b over c is the same as a over c plus b over what, c. So I can write this one as 6x over root of x plus 3 over root of what, x, or dx. Is that right? And then I know that 6x, this is the same as x to the power 1 over 2 plus 3x to the power 1 over 2 because of the root. Then I can write this one as 6x times, so when I move this one up, I'm going to have x to the power minus 1 over 2 plus 3x to the power minus 1 over 2 dx. Right. Multiply. I'm going to have, so indices, when the base are the same, we add the exponent. This is 1. So 1 minus half is going to give us x to the power 1 over 2 plus 3x minus 1 over 2. So you see, I need to go through all this simplification before I even start doing the actual integration. So now let's integrate. I maintain my 6, then x 1 over 2 plus 1 divided by 1 over 2 plus 1 plus maintain 3 minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. Right. So let me just clean, let me say the first top 3 and then shift this one up there so that I can continue from here. Then this is going to be 6 times, this is the same as 3 over 2 divided by 3 over 2 plus 3. This is going to give us 1 over 2 divided by 1 over 2. Now 6 divided by 3 over 2. When I change it, I'll just have this one to be multiplication. Then I need to change this one to be this. 3 goes here, 1 goes here, 2. So I'm going to have 4 x to the power 3 on 2 plus, same thing here. This is going to give us 6 x to the power 1 over 2 plus my c, which is very important here. Yeah. So the idea is that for you to also confirm, when you finish, you can differentiate this to see if we are going to have the function here, differentiate this one to also see if we are going to have the function here, right? So anytime you are done with the integration, what you need to do is try and differentiate and see if you are going to have what is there, right? Now here is find a specific function, right? So the normal integration, but this one will help us to find a constant. For example, you see that we are adding plus c, so we don't know the value of the constant, but this initial value here or initial condition here will help us to find the constant. So let's go. F prime, when I integrate f prime, I'll have f of x, right? So I'm going to have integration minus 3x squared minus 2 or the x. So now let's go x to the power 5 divided by 5 minus 3x cubed divided by 3, right? Minus 2x plus c, right? So this is what you're going to get. Then what can we do? This is the same as x to the power 5 over 5 minus x to the power 3 minus 2x plus c. This is f of x. This is the function. But now we can use the initial condition here to find c. So f of 0 is going to be, this one will be 0 plus c, because this will be 0, this will be 0, this will be 0. Then f of 0 is 5 from the question, and then 0 plus c is 5. So it means that our f of x, is equal to x to the power 5 divided by 5 minus x to the power 3 minus 2x plus the c is 5. So this is the function that what we differentiated. So you can try to differentiate this function, the whole of this function, and you are going to have this one here, the f prime here. Is that right? So that is the idea. Let's look at b. The same thing. When I integrate f prime, I'll have f of x, which will be equal to integration 4 over x cubed dx. I'll factor my constant 4 out. Then I'll have 1 over x to the power 3 dx. Now the power here is not 1, so I'm not thinking about a length function. So I'm thinking about now moving this one up to have something like this. And 4x, I add plus 1, which is going to give us negative 2 divided by negative 2 plus c. And then this is going to give us negative 2x negative 2 plus c. I can write this one as negative 2 divided by x squared plus c. So this is my f of x, right? So now that I've gotten my f of x, I need to use the initial condition here, right? So let me try and clean some of the solution, and then now we use the initial condition to find f of x. So what is f of 2? Because this is 2, so I plug in 2, so this is minus 2 squared plus c. What is f of 2? F of 2 is equal to 1. So we have 1 is equal to minus 2 divided by 4 plus c. So this is 1 is equal to minus 1 over 2 plus c. Add plus half on both sides, and we are going to have c to be equal to 3 on 2. Right. So that is my c. So now I can write my function f of x to be equal to, my f of x now is equal to, f of x is equal to minus 2 over x squared plus 3 on 2. Right. So this is what I'm going to get at the end of the day. So now when I differentiate this function, I'm going to have what is here, right here. So that's the idea. Now let's look at c. Now when I integrate f prime, I have f of x, integrate this plus 6x dx. So let's try and simplify before we do it. So 3x to the power 1 over 2 plus 6x dx. So let's go through the integration. This is 3 half plus 1 divided by half plus 1 plus 6x plus, so 1 plus 1 will be 1 plus 1 plus c. This is going to give us 3, half plus 1 is 3 on 2 divided by 3 on 2 plus 6x squared divided by 2 plus c. Let's simplify. This is like 3 divided by 3 on 2. So this is 3 times 2 on 3. And we are going to have 2. So this one is 2. Then 6 divided by 2 is 3 plus c. So now let's find for c with this initial condition. So what is f of 4? Plug in 4. So 2, 4 to the power 3 on 2 is going to be 2, no, 4 squared here. Let's see. What is f of 4? That one is 1. So 1 is equal to this one, square root of half of square root of 4 is 2. 2 to the power 3 is, I think, 8. Yeah. Plus 16 times 3 should be 48 plus c. Good. So this is going to give us 1 is equal to 16 plus 48 plus c. And then 1 is equal to, when I add, I'm going to have 64 plus c, and c should be equal to minus 63. Good. So yeah, this is what I'm going to get. So now my f of x, the function that we differentiated, is equal to 2x to the power 3 on 2 plus 3x squared plus or minus 63. Yeah, I think this is right. Yeah, this is supposed to be 48, which is right. So this is what you are going to get at the end of the day. Let's look at d. Good. So when I integrate dy over dx, I'm going to have y integrate e to the power x dx. So this is going to give us, so when I integrate e to the power x, I will divide it by the derivative of what is on the top. So when I differentiate 1, I'm going to have, sorry, when I differentiate x, I'm going to have 1 plus c. So this is 2ex plus c, y. Now, y of ln 4 is equal to 3. So let's do that. Y of ln 4. So here it means that x is equal to ln 4. So I'm going to have 2 e to the power ln of 4 plus c. So what is y of ln of 4, which is 3? So I'm going to have 3 is equal to 2. Now, this here can be written as 4 plus c, because this and this will cancel out. So we are going to have left with a 4. And then we are going to have 3, 8 plus c, and c should be negative 5. So my y is equal to 2e to the power x plus, no, minus 5. This will be my c. This will be the function that what we differentiated. This is also the function that we differentiated. Right. So yeah, so for question 3, you can just play around it, you know. Yeah, you can just play around it, find two functions, something like this. So yeah, you can just play around this function here. So let me just help you with the first one. So first one, you can say that f of x is equal to cubic root of x, and the origin of x will be equal to x squared plus 3x. Yeah, so you can just play around the rest of the function here like that. Good. All right, so see you in the next video.